Hello, welcome back. In this particular session, we'll be talking about matrix multiplication. We have seen in last session about matrix multiplication, and we have seen that while we are doing a matrix multiplication, so the condition that should satisfy is that the number of rows of matrix A must be equal to the number of rows in the matrix B. Similarly, the number of columns of matrix A should be equal to the number of columns of matrix B, right? And we saw some example like if you take a matrix like 3 cross 2 and you take a matrix like 2 cross 3 and all, we cannot, do the addition itself, right? Now, we're going to talk about matrix multiplication. Yes. So the metric multiplication, when you talk about metric multiplication, the same way when we are have talked about metric addition, it also has to satisfy one of the rule. And the rule is that two matrices can be multiplied if the number of columns, okay, in the first matrix is equal to the number of rows in the second matrix. So if I take this as my first matrix, okay, and if I take this as my first matrix, and if you see that I have three rows and I have two columns, right? I have three rows, sorry, three rows, yes, and two columns. So 3 into 2. And here, if you see, I have two rows and three columns. So my number of columns in matrix A, this is 2, and my number of rows on matrix B is 2. So now, if this condition is satisfied, then I can easily multiply these two matrices. Okay, so you have to remember that if the number of columns of matrix, first matrix, okay, let's say this is A, okay, and the second matrix is B, and then the columns of A, which is 2, is equal to the rows of B, right? If this satisfied, then we can do the matrix multiplication, right? So these are the certain example. Here we can see that 3 cross 2 and 2 cross 3, yes, because 2 and 2, right? Again, we have 3 cross 3 and 3 cross 3, yes, the number of columns in matrix A is equal to number of rows in matrix B. 4 cross 2 equal to 2 cross 5, yes, number of rows in a number of columns in A is equal to number of columns in B. So if this condition is satisfied, then we can go for matrix multiplication. Yes, so for the matrix multiplication, I'm again saying that the number of columns of the first matrix must be equal to the number of rows of the second matrix. So you can see here the number of columns of first matrix is equal to the number of rows of the second matrix. So number of columns of first matrix equal to number of rows of second matrix. So this, when it is satisfied, then we can have a matrix, okay, multiplication, right? So now we need to understand how exactly a matrix is multiplied, right? So how exactly is multiplied? Let us take the same example. So we have here three rows and two columns, and we have the element 2, 3, 4, 5, and 6, 7 of matrix A, and we have 12, 9, 7, 2, and 8, 1 in this matrix of course 2 cross 3. Right now, whenever you multiply, see this particular number of columns, okay, in matrix A is equal to number of columns in matrix B. Okay, so the first matrix columns is equal to the row of the second matrix, so 2 is 2. Now when you will multiply, okay, you will see the matrix that will generate is 3 cross 3. So that is what we will have, 3 cross 3 matrix, right? So that means the row of the first column will be the row of the the multiplied matrix, okay, and the column, yes, of the second matrix is equal to column of the, okay, the multiplication matrix. So if I consider this to be nothing but a result matrix, okay, so result matrix is nothing but 3 cross 3, the the row of first matrix and the columns of the second matrix, okay, and once we multiplied it, the value that we got is this particular. Okay, now how we have got this value also we'll see in the subsequent slide itself. So I hope you understood this, that whenever you have a matrix multiplication, so the number of the column of first matrix is equal to the row of the second matrix, and the resultant matrix that will be gone is nothing but the row of the first matrix and the column of the second matrix. So row of the first matrix is 3, the column of the second matrix is 3. So we have a 3 cross 3 multiplication matrix. So having said it, this is clear. Now we'll see how we have got this value of 42, 20, 19, all these values. Okay. So now once we have this matrix, now how will you going to multiply a matrix? Okay. The matrix multiplication is like each of this, you can see the cell, right? Okay, so we have this cell, this is one cell, this is another cell, this is another cell, right there. So we have a 3 cross 3 matrix. The first one is the row is 1 and column is 1. Okay, so the value of this is nothing but 2 multiplied by 12 plus 3 multiplied by 9. So first is nothing but 2, we take it 2, yes. Then we multiply this with 12. Okay, I hope it is clear. 2 multiplied by 12. Then we have an addition. Okay, and then we multiply 3, and that we multiplied with 9. Yes. So now we can see 2 multiplied with 12. Okay, plus 3 multiplied by 9. Okay, so we have this. Alright. Now this is for row 1, column 1. For the row 2, so row 1, column 2, again 2 will be multiplied by 7. Again 3 will be multiplied by 2. Again, okay, so we have, okay, so we have like this. So 2 is multiplied by 7 and 3 is multiplied by 2, right? Similar in the next one with row 1, column 3, again 2 will be multiplied by 8 and 3 will be multiplied by 1. Okay, so we have 2 multiplied by 8, 3 multiplied by 1. Now we move to the next row, right? Row 1, 2, column 1. So row 2, column 1 means we'll now move to the next row of this matrix. Okay, the first matrix. Now this 4 will be multiplied by 12. Okay, and this 5 will be multiplied by 9. So we'll have like this here. Okay, 4 multiplied by 12 and 5 multiplied by 9. So similarly, we'll have 4 multiplied by 7, 4 multiplied by 7 and 5 multiplied by 2. Yes, and then we have 4 multiplied by 8 and 5 multiplied by 1. Okay, so next again will come down here. Okay, now we have 6 multiplied by 12 and 7 multiplied by 9. So 6 into 12 plus 7 into 9. Next 6 into 7, okay, and 7 into 2. So 6 into 7 and 7 into 2. Next we have 6 into 8 and 7 into, okay, 7 into 1. You can see it very clearly, right? So 7 into 1, right? So now we got this multiplication. So 2 into 12, it will be 24 plus, 3 into 7 will be 27. Okay. So now we're going to add it and we get the resultant. Okay. Yes. So I'm again repeating 2 multiplied by 12 and 3 multiplied by 9. So we got it for the first cell. Then 2 multiplied by 7, 3 multiplied by 2, we got for the second cell. 2 multiplied by 8 and 3 multiplied by 1. So that means this particular row is multiplying with each of this column. You can see each of this column, right? So 2 is multiplied by 12, 3 is multiplied by 2. So this particular columns n for one single cell. Then again for these two, again it is multiplied by 7 and 2. So second cell is done. So these two again multiplied by 8 and 1. Okay, so if this is clear, then we can understand how we can clear the logic in the next one. Okay, so now having said this, yes, so we got now 24 plus 27, 14 plus 6, 16 plus 3. So this addition, okay, and lastly we get it nothing but 51, 20, okay, 19, 93, 38, 37, 135, 56, and 55. Okay, I make it this color because again 2 multiplied by 12 and 3 multiplied by 7. So 24 plus, so we got it 24 plus 7, okay, which 24 plus 27 equal to nothing but 51. Okay, so that we have got it, right? Now let us understand how we are going to deduce the logic. Okay, so this is something very, very critical here. So let us consider that since we are taking each of this row, right, each of this row of the first column. Okay, so I said this is R1, okay, row 1 and column 1 for the first matrix, and row 2 and column 2 for the second matrix. Now you know that the resultant matrix that is it is created is nothing but row 1 into column 2. That is what we have seen, right? Row 1 into column 2, and column 1 is must be equal to row 2. That is what the rule is. Yes, and the resultant matrix is nothing but row 1 into column 2, because we have seen that matrix, the 3 cross 2 into 2 cross 3 is nothing but 3 cross 3. So now, since we have these two matrix, so the first loop simply it will go for R1, and second loop it will go for the C2. Yes. Okay, fine. Now, see, I take it as I and J. So I will go till R1, okay, and J will go till C2, because that is what the resultant matrix we are creating. Okay. Now we know each of this cell will be multiplied by whom? Multiply this particular value, 12 and 9. Okay. Or right, or it may be down. So this we represent this as K. Yes, and K is nothing but equal to R of 2 or C of 1, because two columns, two rows. That is what the concept. Yes, the two columns, two rows, because the number of columns of matrix first must be equal to number of columns in matrix 2. That is why, that's why that you can do the multiplication. So the most inner loop will be starting from will be from 0 to nothing but C1 or R2. So you can see C1 or R2. Yes, and then we put result j is equal to 0, or it is not required. Also, we'll see in the programming initially if you do equal to 0 also, okay, it does. Okay, now result ij, because that is where we are storing, right? This is ij, right? So row of 0, column of 0, because this is what the implementation that we are doing in C, right? 0 and 0. Now this value 2 is nothing but 0, and k value is also 0, right? So 0 and 0, and k will come from 0 to 1, so it will 0 to 1. So k 0 and 0. Okay, and b, right? B matrix also, this is nothing but 0, so that's why we have k, and j is also 0. Okay, so like that, a of I of k is multiplied by b of k j. Yes, b of k j. Yes, so now once I will be 0 only, right? Because the first row itself we are talking about, and k will increment from 0 to 1. So 0 to 1, because we are going from the row, always row will be 0, and k value will change from 1 to 2 for A. Yes, and here for B, okay, k will change from 0 to 1, but j will be always constant, because j will be always be 0, will be 0, then it will be 1, then it will go. That's why it is k and j. Yes. So try to understand again. I'm just repeating. So since it is a 3 cross 3 matrix that will result, okay, result will not equal R1 into C2. So that is the reason why we have the first loop as the row 1, second row as column 2. That is what we have seen. Yes, because the resultant matrix is that. Next, we have to take the common factor, the rule, which is nothing but either C1 or R2. Correct? Now the result matrix is Ij, because this is what we get it. Now this multiplication is A into I, because we are talking the first row, then we'll take in the second row, then we'll take the third row. That's why it is I. And k will go from where? From 0 to 1. Here also it will go from 0 to 1, right? From 0 to 1, because here the column is changing from 0 to 1, and here the row is changing. So that's why the k here is in A of column, and in the B matrix the row is changing. That is why the k value is first, then the j, because j is coming from again, which is equal to the C2, that value we have done. Yes, so that is what the logic of the matrix multiplication, right? So whatever we do, okay, so always the outer loop will, the first loop will be the row, okay, of matrix, first matrix, then the next loop will be the column of the second matrix. Okay, that is what we are getting. The output matrix is nothing but the row 1 and column 2. And what is the common factor? The column of first row must be equal to the row. That is anything we can take. Yes, and the multiplication will be A of the outer loop, because I will be always be there. Okay, and k value will be changing. Yes, and here in the B, again k value first for the row will be changing. That's what we have seen. So that is the reason why k will come, and j correspondingly will be traveling, will be coming from here 0, to C2. Okay. So let me tell you once again. So because we are having the resultant matrix nothing but R1 into C2. Okay. So that is the reason why the first loop will be will be considering the row of the resultant matrix, and the next loop will be the column of the resultant matrix. That is why the I will go till R1 and J will go till C2. Okay, that's how you have to remember, right? Then you see the corresponding inner loop will be nothing but either equal to C1 or R2, because that is what we are doing the multiplication, right? And so K, that's what we have said, K equal to 0, K less than C1 and K plus plus. Okay. Now the thing is, how will you multiply a of I? Okay, because this is what the first row we are talking about. Okay, and the row represent one nothing but the I. Yes, into you know k value. K value is going till where? K value is going till from 0 to 1, right? Because this is equal to C1 or R2, right? So a of I k, yes, and b will be again will be traveling from 1 and 2, yes. So first row, second row, that is the reason why it is b of k, and it will move till j, right? So of j, yes, right. First it will be j1, j0, then j2, then j3. That is what we have done. J0, okay, okay, j1 and j2, correct? Yes, and so 2 into 12, 3 into 9, right? So 2 is nothing but representing by I of 0, okay, k of 0. And 3 is nothing but I of 0, k of 1. Yes. Now 12 is nothing but what? K of 0, j of 0. Okay. And 9, k of 1, okay, and j of 0 itself. Okay. So that is how the logic itself. So again, I'm telling you that it will be R1. Okay, the resultant matrix will be R1 into C2. So we have the first loop R1, then the next loop C2, and then we have to have the multiplication. How we are doing it? Corresponding to that rule of C1 equal to R2. So either we take it will go to C1, or it will go to R2, right? And the resultant, when you multiply that, it will be A of IK plus multiply into B of K and J. Yes, so I hope it is clear. Yes, in the next session I will show you how to you know how to write the program, okay, in C itself. Yes, okay. So I hope the metric multiplication logic is clear, so that in the next session we can easily write down the program in C language itself. Okay, so thank you for watching my video, and if you like my video, do please share, okay, and share with your friends, and do ask them to subscribe. Thank you so much.